Good morning, dear students. Today in this tutorial I am going to demonstrate GPIO programming. GPIO programming. In this tutorial, LED blinking and LED with switch and LED 10 times by using switch. Three programs I am going to demonstrate in this experiment number 4A GPIO programming. Let us start our session. So simply I am going to the VNC Viewer. I am opening my Raspberry Pi through VNC Viewer. VNC Viewer means virtual network connection. So my Raspberry Pi I am opening through my laptop, in my laptop with the help of VNC server, VNC Viewer. Right? Now simply enter Raspberry Pi dot local :1, enter. It will ask password. Simply Raspberry, enter. Automatically it will open the Raspberry Pi desktop. This is Raspberry Pi desktop environment. Now I have two operating systems. One is Raspberry Pi, one is my laptop, right? One is my laptop. So now simply I am going to programming. I am opening MU. MU is the best Python IDE. Best Python IDE. It is very interactive for writing programming. So dear students, you choose always for this MU editor for LED for Python programming in Raspberry Pi. Now let us start. Now I am save this file. LED blinking. Simply LED blink.py. Save. Yes. So let us start our programming. Simply I am zooming. Okay. Now simply this is good. So first what we need to do. First import Python packages. To access our Raspberry Pi IO pins, we need Raspberry Pi library, pins library. That is, pins library is rpi dot GPIO. This is the package of Raspberry Pi. Every time I am calling this rpi dot GPIO, this is very lengthy. Simply I am shortcut, I am declaring this as GPIO. So whenever I am writing, I am calling the library simply GPIO, or you simply declare two letters IO, whatever you want. Single letter also possible. Next, what else we need? Time. Time is most important. LED blinking 1 second with 1 second delay. So one more library, import time. This is a library for import time. Next, you need to declare the set mode. GPIO dot set mode. GPIO dot set mode. GPIO dot board. Dear students, there are two types of notations. One is GPIO set mode, GPIO dot board. Second one is GPIO dot BCM. So GPIO dot board means simply physical pins you can access directly to the physical pins notation. Physical pins notation means in the Raspberry Pi there are 40 IO pins. In the left side odd number of pins, in the right side even number of pins. Left side 1, 3, 5, 7, 9, 11 like that. Right side 2, 4, 6, 8, 10 like that. You can easily remember the pin numbers. Whereas GPIO.BCM mode, that pin number notations you cannot remember. It is very toughest job to remember those GPIO pins. That's why you always prefer GPIO.board, right? Next you need to mandatory rule is set warnings false. In C language, dear students, we all know that while compiling programming there are some few errors are there, warnings. That warnings you need to disable. I don't want to show the warnings. That's why I am disabling GPIO.set warnings false. Next I am declaring simply LED equal to pin number 7. I am choosing pin number 7. You can choose any IO pin. Okay, I am choosing LED equal to pin number 7. This LED is output device, right? This LED is output device. Same in Arduino pin mode, the LED comma output, right? Like that here also GPIO dot setup. This is a different syntax, you remember. Each board syntax are varies, each development board environments, right? GPIO dot setup, here LED comma GPIO dot out. This is a syntax, dear students. You need to remember this, you need to write like this only. This is a by default inbuilt syntax in our rpi.gpio library. Suppose you are writing gpio out put output completely, it will show you the error, it will give you the error, right? Next, what else? Next, the infinite loop I am writing while true. While true, or you need to declare while one also, no problem. GPIO dot output in Arduino digital write, but here the syntax is GPIO dot output LED comma 1. Next, you need to declare time dot sleep. Sleep means it will sleep up to whatever you are giving the time digit. Here 1, I am giving the number 1. 1 means 1 second delay. Remember here 1 means not milliseconds, whereas Arduino here 1 means delay, 1 means 1 millisecond only it will gives you. But in the Raspberry Pi 1 means it will gives you 1 second. Then you have to you have one doubt, sir, how we can declare the milliseconds? Simply you type simply 0.1, this is 100 milliseconds. 0.1 seconds means 100 milliseconds, right? Like that, you whatever you want, you are declaring microseconds also possible. But you remember time dot sleep, it will simply sleep up to 1 second delay. LED is on, after that it will sleep 1 second. GPIO dot output again LED comma 0, again time dot sleep 1. That's all the programming. So 1 second it will LED is turning on, 1 second delay, LED is turning off, 1 second delay. Now I am compiling the programming. Simply go to run option. This is the run option, dear students. Go to this run mode. Simply you compile the program. Simply I am just press the switch, it will start blinking LED. Now I will turn on my camera for interactive purpose. Camera, right? You see, dear students, see, this is a LED, right? See, this is our Raspberry Pi. It is LED on, off, right? It is continuously turn on, off until whenever you switch on the power supply, right? Next, then second programming. Let us start. Second program. Simply, second program, what it is, I am going to demonstrate switch program. Simply you copy the entire program, go to new, paste it, again save. This is a switch, switch dot pi. I am writing like this, switch dot pi. This is my program, right? So now what are the modifications you need to do here? You declare switch is equal to, suppose 9, switch, sorry, 11 you take, 9 is ground, 11 I am choosing 11, switch number is 11. Now I am declaring here the switch is what it is, switch is input, right? Switch is input. GPIO dot setup switch comma GPIO dot in comma GP pull down resistor is there in each IO pin. You need to, I am accessing pull up resistor here. GPIO dot PUD underscore up, right? I am using pull up resistor because the switch I am connecting switch pull-up resistor from VCC to switch, that simply called as a pull-up resistor. We are connecting one resistor VCC to switch. Suppose switch to ground, that resistor simply called as a pull-down resistor. Based on the connectivity, we may call it as pull-up, pull-down. So you need not connect a external resistor. Simply you directly interface switch, no need to external resistor. There is a inbuilt resistors also available in our Raspberry Pi each pin structure. Now simply I need to write if function, if statement, if so GPIO dot input switch equal to 0. So see this each and every statement, the Python programming is starts at it will maintain some space each and every loop. Simply it will call it as, see in the if statement it will maintain some space, which means the entire program is there in the if statement. That is the indentation notation. Indentation is most important in the Python. You need not um, use any curly brackets, completely eliminate in the Python language, right? That's why this is a indentation notation. Now else, in the else I am simply write 0.1 100 milliseconds. Simply if see whenever switch press, it will automatically on off. Whenever not press any switch, automatically it will goes to else loop. Else in this else nothing, nothing, I am not declaring anything here, nothing. Simply 100 milliseconds it will execute. Now let us compile this program, right? Compile this program. So I am compiling. Some error it is there, sleep means here I am using sleep a GPIO dot. You need to declare here a time dot, right? See error, that's why this mu editor is suggestible, because it will show where it is error. It will indicates with number also, with line number also. Now I am compiling. See there is no error. Now I am demonstrating with my camera. See this is camera I am opening. Let us see. See dear students, this is a LED, this is a switch, this is LED, right? This is our Raspberry Pi board, Raspberry Pi 4. Now I press the switch here. See LED on off. Again I press LED on off. Again I press. Simple, right? I hope you understood. Now how to turn on off 10 times. Whenever I press the switch, LED 10 times on off. I am writing counting program, right? Again Control C, copy, go to new, paste it, save the program. Hey, switch underscore LED 10 times dot py, right? Save this program. What else we need to do, dear students? Simply if statement is there here, go to enter. Here you need to write simple for program, for loop, for I in range. Their notation is different, dear students, in the Python. For I in range 0, 10. Whereas in C language, actually what it is, for I equal to 0, I less than 10, I plus plus, right? But in the Python syntax is different. For I in range, whatever is the range you need, simply you declare that range here 0, 10. I want to, whenever I press this switch, LED 10 times it will on off 10 times. After that it will waiting for switch. Whenever the user press the switch, automatically LED is 10 times, because I am declaring the count here 10, right? Now let us see. Start. Now I am starting. Again I am demonstrating with interactive camera mode, right? See dear students, this is our LED. Now I am press this switch here. See, 10 times exactly. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. See, exactly it will count 10. Now see, I am declaring the whatever count you want, you declare it here. Once you are writing counting program, whatever, suppose here you type 1000 times, it will on off. Suppose you declare simply 5, it will 5 times on off. Now again I compile the program, you check it now. 5, I am giving 5 now. So go to this, right? This is again now put 5 times, right? I am press this switch. 1, 2, 3, 4, 5. That's all. See the pin diagram, the Raspberry Pi, these are the pins. I am using pin number 7 and pin number 11 and 2 ground wires, right? Thank you. I hope you understood how to write the simple programming. Thank you one and all.